Okay, we're taking a look at problem 7, chapter 6, solving a simple centroid where we have this shape here with this little cutout here. So again, we're going to have to divide this up into little pieces that we can handle. A couple different ways you could do it, but what I'm going to do is divide it about a line here. So what we're going to do is put a dividing line right here. And so what we're going to have is a triangle, a rectangle, and a triangle void. So we're going to call this shape 1, shape 2, and shape 3. So this guy is 9 inches this way, 3 this way, and we are 6 this way. This is the origin here, and the x-axis is running along that face, and the y-axis is running along that. So we're going to set up our chart, shape, area, x, ax, y, and ay. So we'll start with the triangle shape 1, and it's 3 inches by 9 inches, so that's 3 times 9 times 1/2. That gives us 13.5 square inches. So we have a origin this way, so our x-bar distance for shape 1 is going to be over. It would be 1/3 of the total. So 1/3 of 9 is 3. 3 times 13.5 gives us 40.5. And again, unit would be squared units, squared inches, inches, inches to the third. So y is the distance from the origin up to this guy's centroid. So from here up, it would be 1/3 of 3. That's 1 plus 2 plus 1. So y would be 4. 4 plus 13.5 gives us 54.0. Okay, so we'll take a look at shape 2. Shape 2 is much simpler. It's a rectangle. So we have 3 times 9 gives us an area of 27. The x distance is just half of 9, so that turns out to be 4.5. A times x gives us 121.5. Y is half of the distance up, so that would be 1.5. 1.5 times the area gives us 40.5. Okay, so the last thing we have to deal with is this void. This is a 3 inch by 3 inch. This is shape 3. So this will be a negative area. 3 times 3 times 1/2 gives me 4.5. And don't forget to make that a negative because this is a voided area. So the distance here from its local origin over would be 1/3 of 3. So that's going to be 1 plus 4. So we have 4 plus 1 gives us an x value of 5. 5 times the negative 4.5 gives me a negative 22.5. So the y, we are up, see, we're up 1/3 this way. So it would be 1 plus 1, so 1, and then another 1. So that gives us 2. 2 times the negative area is going to give us a negative 9. So we're going to sum, and sum. So when we take and add these algebraically, we get 36. And we're going to get some of these algebraically, 139.5. And the sum of these algebraically 85.5. Okay, so the x bar distance is the sum of AX's divided by A. So we have 139.5 divided by 36 gives us 3.875 if you carry it out 3. The y bar distance is the summation of AY's divided by the sum of the area, and that gives us 85.5 divided by 36, and that gives us 2.375. Okay, so if we were to put these guys on there, what we would see, let's see, 3 point for the x, so this is 9, so we are about somewhere about right in here for the x bar, and 2.37 would be somewhere maybe about right here. So this would be, oops, the x bar distance. Get rid of those diagonals. So this would be your x bar distance. And your y bar distance would be the distance from here to here. And so you should kind of always try to visualize that when we get that.